right, hi everyone. I'm Tatyana Casino. Welcome to my session. Really excited to be here. It's my first time speaking at 360 and Dev. I'm a software engineer. I do Android development at a company called WillowTree. So we're a mobile agency that develops mobile apps and websites for different clients. And actually, we evolved to do a lot more things than that. We have 2 offices, so we currently have an office in Charlottesville, Virginia, so that's where I'm from, and we have another office in Durham, North Carolina. Please check out our website if you have an opportunity for that. And today we're going to talk about machine learning on Android, and my goal today is to give you a good idea of what does it actually take to implement this in your Android apps and give you some things to consider before we get started. Maybe some of you have seen this XKCD comic, which basically says that machine learning is just a big pile of linear algebra, and no one really knows what's happening there. You just keep stirring the pile until the answers start looking right. And to some degree, it's actually true. But let's try to be a little more serious and understand what machine learning actually is. So that is the area of computational science that focuses on analyzing and interpreting patterns and structures in data. So it's about finding patterns in data and getting better at predicting results over time. And usually you hear 2 terms, machine learning algorithm and machine learning model. So what is the difference between those 2 things? So you can think of machine learning algorithm as like a generalized correlation between inputs and outputs, whereas a machine learning model is the result of training the algorithm on a specific data set. So it has specific parameters for a correlation. And of course, there's a huge amount of different machine learning algorithms, and we're not going to cover them in this talk because we simply won't have time. However, I would like to suggest you to check out the Neural Networks Playground, which was created by TensorFlow. It's really fun. So if you want to understand how neural networks work, this is a great place to do it. So you can just create neural networks right there in your browser and experiment with data and see what comes out. Well, before we go into the woods with machine learning, a good question to ask yourself is, can my task actually be solved with machine learning, and is it actually possible? Because it's important to remember that this is all dependent on data. So if you get garbage data, you're going to get garbage as results. And you cannot expect machine learning methods to give you any knowledge outside of the data that you provided. And it's really important to know the specific domain area that you're developing your machine learning app for, and do the research. And in some cases, you might find that you actually do not have enough data. A good example for this could be like, say, for example, you have a client who is a chain of stores, right? And they have collected data over 3 months. But the thing is with that data is that it was collected during holiday season. So, Thanksgiving, Christmas, and Black Friday is also a thing. And now they want you to get some machine learning insights from that. And so obviously this isn't going to be accurate because people can go really crazy on Black Fridays, and it's not going to be the same during different seasons. And so you really need to understand, have some kind of domain knowledge. And think about edge cases, and make sure that your data set is inclusive. So for example, if you're working with face detection, you need to include, in your data set, you need to include photos of people with different colors of skin and different facial features. One thing that can happen with machine learning is overfitting. So sometimes it can happen that a model performs really well on training data, but much worse on unseen data. So if you have created a machine learning model that seems to work well on a simple example, please do not assume that it's going to work for just every single data set out there. I think the picture really describes it well. There are also some bad cases for machine learning. So we talked a little bit about extrapolation already. If you have some kind of new or unknown factors coming in, but your data is based on some history without those factors being present, then you cannot really rely on machine learning to give you accurate results. Like also this example from XKCD. Also, you need to be mindful of your audience, so the user segments that you're trying to serve. So say, for example, you have an app that allows users to book doctor's appointments, right? And you think, okay, well, maybe I can use machine learning to suggest your users when they can schedule their next visit. But one thing to remember here is that there's a segment of people who have, for example, chronic illnesses, right? And those people have to go to the doctor a lot more often than healthy people. And so this is studying your audience and doing the user research is also really important for your machine learning app to be successful. And another good question to ask is, can a human do this task successfully? Because, okay, well, wouldn't that be awesome if we had an app that could detect the amount of calories or maybe possible allergens from just pointing a camera at food, and it could tell you, okay, this has gluten in it, so you shouldn't eat it. But can it really be successful? Because I don't think I can actually tell a difference with these bread images, for example. So on the top row we have bread with gluten, and on the bottom row we have the gluten-free bread. Do you see a difference? If you do, then you must be really special, because I can't. And another question that comes up often is, how much math do I need to know? And the short answer is, to implement machine learning in your apps and use machine learning frameworks, you don't really need to know too much math at all, but it certainly will help you if you want to really gather and analyze the data and figure out why your machine learning model isn't working really well. So let's take a look at a machine learning process as a whole. So the first step to do machine learning is to gather data. Then the second step is to prepare it and clean it and make it, transform it into a format that machine learning model can consume. Then the next step is you can either create a new machine learning model, so you can build the model architecture from scratch by yourself, or you can choose an existing one. And then you have to train the model on your data set. And one important thing to remember here is do not use all the data that you've collected for training the model. You need to set aside a part of the data for testing the model later. So then you can figure out if your model is performing actually well or not. The second step is evaluation. So we need to evaluate your model against the data that was excluded from the original training set. And then finally, you can do some extra tuning, because some models can have hyperparameters that are not dependent on data. And the final step is actual predictions or inference. And so inference can happen in the cloud. So you can have cloud machine learning services, and inference can also happen on device. So the difference between these is that for cloud machine learning, the model is not going to be directly accessible. And to you as a client, we're making all the network calls, passing your data to the servers. Whereas on device, the machine learning model is going to be stored locally, and you won't be making any network calls, and everything is going to happen only on device. And then finally, you can also have your custom setup. That is, you can totally spin up your own server and upload your custom model, because why not? There are different pros and cons for cloud machine learning. So as I just mentioned, it's all you have to do as a client, you have to just make network requests to your cloud machine learning service, and then just handle responses. It's as a developer, this is something we're familiar with. So we don't really actually have to understand how this model works. You don't have to host to serve the model to user devices. You don't have to worry about training and retraining the model. It's because it's going to constantly be improved by the provider of cloud machine learning services. But of course, there are also some cons, and one of them is pricing, because all the cloud machine learning services probably want you to pay per the amount of requests, and they can get expensive really fast. Also, for people who want to create their custom models or who have some kind of specific unique use cases, there could be some limitations in how you're able to configure this machine learning in the cloud. And obviously cannot work without the internet connection. There's also an issue of latency, so it's not really a good choice for real-time processing apps because it takes time to make the request and then handle the response, and your users most surely will notice it. And finally, there are also some privacy concerns because if you're passing sensitive data to the servers, there's a risk of that data being stolen. So this is where on-device machine learning comes in, and in this presentation, we're going to focus on that more. As an overall trend, we can notice that there's an increasing push towards on-device machine learning. And talking about Android specifically, in Android P, machine learning was integrated into the entire operating system, and it's used to predict which apps are being used at a particular time. And that allows the operating system to adapt to your habits. Then on Android Q, for example, we have Smart Reply, so it's going to be built into the notification system, and it will be available in all messaging apps. And some other interesting examples of on-device machine learning that you may have heard of is live caption. There's also Google Lens suggestions and Google call screening. So yes, all of those are happening strictly on device, and perhaps Google call screening is one of my favorites here. And also there have been some advancements in mobile hardware. So perhaps you have heard of so-called AI chips. So some major chip makers are starting to make their GPUs more powerful and integrating NPUs, which are neural processing units. So those are microprocessors that specialize in performing machine learning algorithms in the most effective way. And one of the good examples is Google's Pixel Visual Core. So that one was first featured in Google Pixel 2. And if you're more interested in how different devices perform on different machine learning tasks, I could recommend you to check out the website called ai-benchmark.com. So it has a comparison of many different Android devices, and they evaluate on tasks like object detection, image classification, and others. Looking more closely at on-device inference, so there are some obvious advantages here. So first one is low latency. So if your application is handling some real-time data, like you're manipulating some kind of live video, or you're doing something really fancy with augmented reality, then you should definitely go with on-device machine learning models. Like this fun example is the Insta Saber app up there. And then with on-device machine learning, you can also handle the issue of no connectivity, because there's still a lot of places in the world where access to internet is either not available at all, or is bad or expensive. And we should also think of that segment of our user base. Another advantage is privacy as well, because the data will never leave the user's device, and if your application is handling some kind of personal data, like for example face scans or health data, majority of people wouldn't be comfortable of that data being constantly sent to servers. And then also another advantage is lower cost, so that means that you don't have to pay for hosting your models in the cloud or maintaining your own backend. But of course, there are also some drawbacks there as well. So we need to remember that even though mobile hardware is advancing really fast, we're still in a limited resource environment. And machine learning inference is a heavy computational process. So we need to really be mindful of how we're using our battery, and make sure to maybe run some benchmarks there as well. And there is also going to be a trade-off between models' performance and accuracy. So generally, when you optimize or shrink a machine learning model to be used in a mobile app, there could be an accuracy loss. And so smaller models, they usually tend to be faster and more energy efficient. They could also be less accurate, so that is something that we should be mindful of as well. Then, if you bundle your machine learning model with the app, some types of models can take multiple megabytes of memory. So if that is a concern to you, you might want to consider downloading the models after your app installation, or maybe consider using smaller models instead. And another thing to think about is how are you going to update your machine learning model. So say, for example, we found a significant flaw, and now you have to push that machine learning model to the users. So do you want to just update your whole app, or you could just update your machine learning models in the background and just keep delivering them to users as you keep improving the performance of your machine learning model. So that's something you may want to think about as well. And then finally, there's an issue of model security, because we all know that apps can be reverse engineered, and that means that a machine learning model, which is not the resources, can be stolen. And that may be a real concern to you if you have developed a custom machine learning model and it has like some really valuable insights or architecture that you worked really hard on. So now let's talk about frameworks for integrating machine learning in Android apps, and we're going to look at TensorFlow Lite and MLKit today. And obviously there are also third-party SDKs which are worth checking out, but we're not going to cover them today. So let's start with TensorFlow Lite. So you may have heard of TensorFlow machine learning framework. So TensorFlow Lite is a lightweight version of that, and it works on Android, iOS, and embedded devices as well. So it allows you to perform machine learning inference on device. It supports hardware acceleration using Android neural networks API, and its operators are specifically tuned for mobile platforms. And also, one interesting thing to note is that there are already TensorFlow Lite models that are available and ready for use in mobile apps. So that means they have already been trained and optimized, and all you have to do is just to include that model. So I want to say a few words about Android Neural Networks API as well. So as app developers, we don't really need to know about it in depth. So that is actually a lower level API that the developers who work on a machine learning frameworks we need to use. But basically what it does, it allows access to the dedicated neural network hardware, GPUs, and DSPs. And machine learning frameworks use it to perform hardware-accelerated inference operations. And it's available starting from Android 8.1. So what are the actual implementation steps for adding TensorFlow Lite model into your app? So the first step, obviously, you have to choose a pre-trained model or retrain an existing model, or build something custom from scratch. Then if your model has not been converted to TensorFlow Lite format yet, you have to do that and maybe make some optimizations. Then you need to integrate the model into your app, and that means you have to load the TensorFlow Lite model into memory, do some pre-processing on your data. So in a lot of cases, the input data format that we receive from users is not what a machine learning model will expect as its input. So say, for example, you have an app that's you can take pictures with and then maybe do some object detection on that. So your input is an image from camera, right? But this is not the input that machine learning model is expected. So you may need to resize that image or represent it in an array of floats. Then you have to initialize and build the TensorFlow Lite interpreter, and then run the prediction on that interpreter, and then you need to present the results in a meaningful way for users. So here's a general overview of how TensorFlow Lite SDK is being used. So first step is to add Gradle dependencies. And we also need to make sure that Gradle doesn't compress the models when we're building the app. And we do that by adding a no compress option. Then the next step is to load the TensorFlow Lite model file from assets directory. This is an example function that loads the model file and returns the map by buffer. And then the TensorFlow Lite interpreter is the class is going to run, perform the predictions. So we have to pass your loaded model file when you initialize that interpreter. And then, as I mentioned earlier, we may need to perform some input data conversion. So this is like a very general example, because for your use case, this might be different depending on what kind of data you're working with. Could be text, could be images. But generally, machine learning models accept multidimensional arrays as input. So you have to work with your data to perform that conversion. Create data structures for outputs, and then finally, interpreter.run is going to run the inference with your machine learning model. And I would recommend to check out more specific examples for gesture and image classification, object detection. So those examples were created specifically by TensorFlow, and you can check them out and compare how the interpreter is being set up and how the input data is being converted for all those different cases. So let's talk a little bit more about TensorFlow Lite converters. So usually all the machine learning models are being developed with machine learning frameworks like TensorFlow or Keras, but to be able to include this model into your mobile app, you have to convert it to TensorFlow Lite format. So that means you have to take the protobuf TensorFlow file as an input, or HDF5 Keras model input, and then a .tf Lite file will be generated by TensorFlow Lite converter. It's one thing to note here is that certain TensorFlow operations may be incompatible with TensorFlow Lite, so we definitely need to check with the documentation and make sure that the model you created will be able to seamlessly convert it into TensorFlow Lite format. And specifically, that can happen to recurrent neural network architectures. And TensorFlow Lite converter can be used either from command line, or it can be used with Python API. So Python API is what's being recommended by TensorFlow. So these are little code snippets in Python here that perform this TensorFlow to TensorFlow Lite conversion. So first example is for TensorFlow saved model conversion. And then second example is for Keras model. So, I mean, this really isn't too difficult if you're a little bit familiar with Python. So I guess the really big thing here is to make sure that operations are compatible. And one of the techniques that is being used for optimizing machine learning models for mobile is quantization. So basically that means is that we're changing the precision of the weights in a neural network, for example. So I guess one good example that I think explains well is when you're checking for forecast, how detailed and granular do you want that information to be? Like, do you need the exact number of droplets per second if you know it's going to rain? So do you really need that level of precision when you're making your plans to go outside? Or you just want to know, is it going to be light rain or heavy rain? So there's a difference, right? And so in some cases, we don't really need high level of precision. So that really is going to depend on use case. And you need to be mindful here because in some applications you cannot really afford lots of accuracy. So say, for example, your app wants to detect some kinds of poisonous plants, and if the model returns inaccurate results here, that there could be obviously more serious complications, right, than just from labeling cats or dogs. But yeah, basically what happens is weights in neural networks are being transformed from floating point to lower bits of precision. And I also included some charts here to give you an idea of how quantization can affect the size of a machine learning model and its latency. So one thing here is it could be different for different types of models. So here is an example for some well-known image classification models like MobileNet and Inception. And the tendency we can see here is that usually with larger model size, there's going to be larger latency, so it means it's going to take the model more time to perform a prediction. Then here's the model size versus accuracy chart. So another tendency here we see also for image classification models is that with larger size, we also get better accuracy. And then another comparison here is taking a look at accuracy versus latency. So this is for an image classification model called MobileNet, and it compares the 8-bit inference mode and float inference mode. And here we can see that those are getting pretty close together, but this, I guess, accuracy trade-off can be really dependent on the model and the use case. So those are like examples of what you could expect. And so definitely you need to perform some testing, and after you optimize your machine learning model, and make sure how changing different parameters affects your results. And TensorFlow has a benchmarking tool that you can check out, and there's also a tool called TensorBoard, which allows you to visualize the machine learning model graph and plot some graphs and metrics there. So how do we perform this quantization with TensorFlow Lite converter? So this is another little Python snippet I included here. So basically you need to call the converter.convert and make sure that you enable quantization as an option, an optimization parameter there. So really nothing like super difficult here. And you can read more about it in the post-training quantization link I included here. And to kind of sum it up, we can see that post-training quantization can reduce the model size, it can lower inference time, and there can be a little degradation in model accuracy, but we shouldn't just like assume things, and it's always best to perform a lot of testing on your models. And in some cases, accuracy loss could possibly be recovered after retraining your quantized model. And so I definitely recommend checking out TensorFlow's optimization tools and some best practices on how to make the best of your optimized model. And another note I wanted to make here is we recently, TensorFlow has had an experimental feature for GPU delegates. So basically it's taking advantage of the GPU speed up, and using it is also really simple. So when in your app you're creating your TensorFlow Lite interpreter, you can just add this as an option when you initialize it. And overall we can say that this GPU speed up is going to be most noticeable on complex neural network models, but on very small models it's not going to be that much different. And if the GPU operations are not supported, then they're going to automatically fall back to CPU. And you can check the list of supported operations on TensorFlow website. Now let's move on to Firebase MLKit. So basically, what it is, it's the ready solutions for both Android and iOS. So it includes some base APIs for a variety of use cases. It allows you to do on-device machine learning and cloud machine learning, although this may vary by the type of their API. And if you want to use cloud options here as well, make sure to check out what their pricing is. And I guess the biggest advantage of it is that it can host and serve custom TensorFlow Lite models to your app, and you can configure whether you want the app to use the model from your local source, that is the model that's bundled from your app, or the model that's being retrieved from the cloud. So MLKit actually has a lot of features, and I'm realizing I wouldn't be able to just cover everything here because they keep adding on new things. And so in this presentation, I decided to focus on the most recent ones. They were added to Firebase MLKit, so that's going to be natural language processing, smart reply, and AutoML Vision Edge. But overall, there are many different use cases. There's text recognition, there's face detection, barcode scanning, image labeling, landmark recognition, and also custom model support. So the basic workflow for using MLKit is, first of all, you need to set up Firebase for your project. Then if you would like to use a cloud-based API, you have to enable that option in the console. Then you need to integrate the MLKit SDK into your app. Then again, similar to TensorFlow, you still need to prepare the input data. So for example, I have to capture the image from the camera and do some transformations there. Then you have to pass that data to the machine learning model, and finally perform the predictions and interpret the results. So let's take a look at the translating text API. So that's one of the new ones that Firebase has recently added. And so at this time, MLKit currently supports translation between 59 languages. And you can visit their website to check out what those languages are. And one note here is they recommend to download those translating text models using Wi-Fi, since the size can be about 30 megabytes, and so that might be a concern for you. And it's also recommended to delete models that you're not using anymore. Yeah, the first thing is, of course, we have to add the MLKit natural language dependencies in Gradle. And then we need to create the Firebase translation options. So here we'll be setting the source language, for example, English, and target language, for example, German. And then we can create the translator object here. And then the API itself actually is really simple. So a translator can download the model if that's necessary. And then we have some listeners here for success or failure. And then you just call translate and then pass the string with the text you want to translate it. And also we have some success and failure listeners, so really nothing super difficult here as well. And then Firebase Translation APIs also has this class called Translate Model Manager. And so it allows you to get available models that are currently stored on your device. And if you want to clean up some space, you can also delete certain models like they recommend in the documentation. So that would be that would happen by creating the Firebase Translate Remote Model Builder. And then on the model manager, you'd have to just call delete downloaded model. Now let's take a look at Smart Reply. Smart Reply, well, I think probably most of you are familiar with this. So it's those little suggestions that pop up whenever you type your message. So MLKit Smart Reply model checks up to 10 of the most recent messages in your conversation history. And first thing it does, it has to detect the language of conversation. And at this time, it only supports English. So if you plan on using it for other languages, unfortunately, that is not possible this time. Also important thing to note here is that the machine learning model for Smart Reply is not going to offer any suggestions if it detects a sensitive topic. And it's going to provide 3 suggested responses. And similarly to what we saw earlier, we have to include Firebase ML natural language, Smart Reply dependencies in Gradle. And then we need to create a conversation history object that a Firebase API can work with. So that will be a chronologically ordered list of Firebase text message objects. And so those objects are going to be created for either local users, so that's the user of your app, or it can be created for remote users, so that is the person that the user of your app is communicating with. And so it's important to note that difference. So Firebase text message needs to obviously have the message text itself, and also needs to have a timestamp because we have a chronologically ordered list here. So these 10 messages are going to, last 10 messages of this conversation history are going to be used for a model to generate 3 smart replies. And then we need to get the instance of Firebase natural language smart reply, and then just calling suggest replies on your conversation list. Then we also have success and failure listeners, and then we can just check the status of the result here. So it's possible that language is not supported, and then in that case, the result is not going to contain any suggestions. And then we have the failure listener as well, and then we can just go through all the suggestions in the result. So really also nothing too difficult here. Now let's take a look at AutoML Vision Edge. So it has been recently added to Firebase MLKit APIs, and you may have noticed earlier that MLKit also has a base image labeling API, and it also has AutoML Vision Edge. So what's the difference? So the base image labeling API in MLKit can recognize around 400 types of objects, but the thing is, most likely it will not be really applicable to your use case, because it just only has labels for like the most general kinds of objects. So it's not like, for example, for a certain narrow domain. So say you want to detect only certain types of plants, right? So you only need to train your model on those specific examples. But like MLKit's base image labeling API, not going to know. It's not going to have the labels for those specific types of plants that you want to recognize. And so for those narrow domains and specific use cases, it's better to use AutoML Vision Edge. So it allows you to train the model with your own images. And Google has also created an inclusive machine learning guide. So say if you're using images of people in your you're going to use images of people in your application, then you should definitely check that out to make sure that your data set is inclusive. And then you need to provide your data to Firebase. So that means you have to assemble your training data. You can do it either by creating a structured zip archive with your images in there, or you can create a cloud storage with CSV index, or you can just upload the unlabeled images into the Firebase console and then just label them later after you uploaded them. And so the workflow for AutoML Vision Edge will be training a model using your images. So that's going to happen in the Firebase MLKit console. Then you need to select the model latency and size. Firebase is going to give you some options there. And the most important part is to evaluate performance metrics for the model and make adjustments if that's necessary. And then finally, you should publish the model, so that means you'll make it available for your app to use. Then let's take a look at using custom models with MLKit. So you can host your models using Firebase, and that's a really good idea, because you'll be able to make sure that your app is always using the most recent version available of your model. You can perform on-device machine learning inference. And you can either bundle the model with the app, or you can host it in the cloud, or you can even do both. So I think that's really great that you can specify these multiple model sources, and you can use a locally stored model when the cloud-hosted one isn't available. And Firebase also helps you with automatic model updates, and you can set specific conditions on when that can happen. So for example, you can require that the app will download the new versions of machine learning models only when the device is charging or on Wi-Fi. And so what are the implementation steps for custom models? So first thing is you need to either find a model or build and train your own. You need to convert it to TensorFlow Lite format if it hasn't been converted already. Then host your model with Firebase, and finally use this model for inference in your app. As always, we need to include the Firebase ML model interpreter, Gradle dependencies, and if you decide to host your model on Firebase, you also need to add internet permission to Android manifest. And because we're using custom models here, we also need, like in TensorFlow setup, we also need to make sure that Gradle is not going to compress the model when you're building the app. And then the model can be included in the app package and available to MLKit as a raw asset, so you can set the asset file path there and register it as a local model source. And then here's how you can set those download conditions that we talked about. So you can require Wi-Fi, you can require charging or idle device, and then you're going to pass those parameters to conditions builder. And then on Firebase Cloud Model Source Builder, you can pass those conditions as initial ones, or you can use those conditions for model updates only. And then finally, register cloud model source is how you choose which model is going to be used for cloud option. And for the cases when you have borrowed your custom machine learning from somewhere else, but I'm not really sure how to, I guess, what types of input data you should require, then you can use the TensorFlow Lite Python interpreter to inspect your model. So if you load this model into TensorFlow Lite interpreter and then get input details and print them, so it can give you an idea of what format it is in. And you can also refer to some TensorFlow Lite docs for more information on that. And then finally, performing inference for custom models. So again, we need to pass the inputs and outputs, their formats, and then just run the Firebase interpreter in this case. And then we just have success and failure listeners, and then get outputs from the results. So again, really nothing super tricky here. And also want to say a few words about cross-platform machine learning. So I have done a little bit of cross-platform development as well. So some people might be interested in it. It's for machine learning specifically, I haven't really looked into it so deeply, but I wanted to give you some references if you wanted to check it out and maybe to contribute to some of those projects. So we have Xamarin, Flutter, Kotlin native, and React native cross-platform frameworks, and seems like the state of machine learning there is kind of, I guess, vague, or it's a work in progress. So if you're interested in cross-platform development, this is an opportunity for you to contribute to those projects. And to sum it up, we have looked at two mobile machine learning frameworks today. So that's TensorFlow Lite and MLKit. And TensorFlow Lite, we could say that it's best for device-only inference. And if you're not going to use any cloud fallbacks and you want it to use it completely for free, then it could be a good choice. Or if you want to take advantage of more advanced configuration and have model updates handled for you by Firebase, then you should go with MLKit. And a few more reminders here. So it's, if you're training your own model, it's important to be thorough and inclusive with the data. Make sure that you have enough data and you have the basic understanding of your domain that you're creating your app for. And please give yourself time for optimization of those machine learning models, because as probably you have noticed, the actual implementation and integrating the SDKs, that isn't really a hard part. So, okay, well, you can just like check out the documentation and do these things. It's really nothing complicated happening there. But preparing the data and optimizing the models, this is where it gets really tricky. And so if you're going to work on a project that involves machine learning, please give yourself time for that experiment and tweaking different parameters, and please be mindful of accuracy trade-offs and how much accuracy you need for your specific use case. So basically just keep testing, keep researching, and as a final word, I'd like to encourage everyone to play with machine learning in the free time. And luckily, MLKit especially makes it fairly easy for developers if you use their base APIs. So this is going to be fun. So I'm really happy that I had the opportunity to talk to you today, and I'll appreciate any questions or feedback that you have for me. So I'll be here today and tomorrow. So please come find me if you have any questions or comments or thoughts or feedback. I'll appreciate it all. Thank you so much. Thank you.